Hello students, in last lecture we have studied about ideal fluid and variation of pressure with height and so on. Now today we are going to discuss about Pascal's law. Pascal's law. According to Pascal's law, in an enclosed liquid, if the pressure is changed at a particular point, this change is transmitted to the entire without being diminished in magnitude. In an enclosed liquid, if the pressure is changed at a particular point, this change is transmitted to the entire liquid without being diminished in magnitude. It means हम किसी भी इनक्लोज्ड लिक्विड के किसी पॉइंट पर कोई भी प्रेशर अप्लाई करें, जितना भी हम प्रेशर वहां पर लगाएं, दैट प्रेशर इज ट्रांसफर्ड इन each and every part of the liquid without being diminished means कि सेम वैल्यू में ये ट्रांसफर होता है. जितना हम एक पॉइंट पे प्रेशर लगाएंगे उसके सारे पॉइंट्स पर हर पॉइंट पे लिक्विड के अंदर उतना ही प्रेशर ट्रांसमिट हो जाएगा. वो किसी भी जगह पर हम उसको ऑब्जर्व कर सकते हैं. तो ये पास्कल्स लॉ जो है एक्चुअली बहुत बड़ी प्रॉपर्टी है ये लिक्विड की, और इसको हम कई जगह यूज करते हैं. फर्स्ट एग्जांपल ऑफ इट इज हाइड्रोलिक प्रेस. एग्जांपल्स ऑफ पास्कल्स लॉ. फर्स्ट एग्जांपल इज हाइड्रोलिक प्रेस. This is the diagram of hydraulic press. Here a piston of cross section, and in the same level here the another piston of cross section A1 and A2. Cross section A1, here the cross section A2. Here we want to lift a car very high. Here we applied the small force and some liquid is filled in the hydraulic press. Here the weight of this arm is W1. Here weight of car is W2. Then according to Pascal's law, pressure which is applied at the arm A1, that will be equal to W1 upon A1 will be equal to W2 upon A2, because it is transferred as it is throughout the volume at each and every point of the liquid. Then if area of cross section is greater, then the pressure is transferred is the multiple of the area. Because area is 100 times greater, then we can say it can be lifted 100 times more weight, or it can be also represented by F1 upon A1 is equal to F2 upon A2. If the area of cross section A1 is pi r1 square, where r1 is the radius of the piston A1, where r1 is radius of piston A1 and A2 is pi r2, where r2 is the radius of piston A2. And then W1 upon A1 is equal to W2 upon A2, or we can write W1 upon pi r1 square is equal to W2 upon pi r2 square, or we can write W1 upon r1 square is equal to W2 upon r2 square. This is Pascal's law. We can take the example, numerical example on the Pascal's law. Let area of cross section of thin tube is 1 centimeter square and the broad tube is 1 meter square, and F1 is applied at thin side is 1 Newton. Find the weight which will be lifted at broad side. We know that W1 F1 upon A1 is equal to F2 upon A2. F1 is 1 Newton. Here F1 is equal to 1 Newton. F2 to be find. A1 is 1 centimeter square, that is 1 by 100 into 100 meter square, that is 1 10 is power minus 4 meter square A1, and A2 is 1 meter square. Now here F1 1 Newton upon A1 is 10 is power minus 4. F2 to be find, and A2 is 1 meter square. Now F2 will be equal to 10 is power 4 Newton. It means when we applied the force only 1 Newton at the thin arm, then by the help of this force, by the help of actually हम कह सकते हैं कि जो apparatus है हाइड्रोलिक प्रेस जो है हमारी, उसमें हम एक तरफ बहुत थिन ट्यूब लेते हैं, दूसरी तरफ हम ब्रॉड ट्यूब लेते हैं जहां पर बड़ा पिस्टन लगाते हैं. तो इफ एरिया ऑफ क्रॉस सेक्शन इज वेरी वेरी ग्रेटर देन द थिन ट्यूब, देन अकॉर्डिंगली वी कैन लिफ्ट द मोर वेट थ्रू इट. इसको हम कई जगह यूज करते हैं. आपने देखा होगा कहीं भी जब हम कार को ठीक कराने जाते हैं उसके, तो उसको एक एक हाइड्रोलिक प्रेस के थ्रू 1 मिनट में काफी ऊपर कर देते हैं. या ट्रक या बस भी आपने देखी होगी कहीं पे जहाँ पे वर्कशॉप होते हैं इनके, तो उसको हाइड्रोलिक प्रेस से उसको काफी ऊपर उठा लेते हैं, ऊपर लटका देते हैं एक तरीके से. तो बहुत कम मतलब हम प्रेशर अप्लाई करके, फोर्स अप्लाई करके और इसको हम उठा सकते हैं. जैसे हमने देखा कि अभी यहाँ 1 न्यूटन फोर्स लगा रहे हैं, 10⁻⁴ न्यूटन फोर्स हमको दूसरी साइड में फाइंड आउट हो रहा है. मतलब हम 10⁻⁴ न्यूटन वेट उठा सकते हैं इससे, हम 1 न्यूटन वेट लगा करके केवल. तो इट इज वेरी इंपॉर्टेंट फिनोमेना ऑफ लिक्विड. नाउ सेकंड पॉइंट इज pressure is independent of shape and size of the container. Pressure is independent of shape and size of a container. It is directly proportional to depth. Pressure is directly proportional to depth. For example, this is a container, this is another container with the same level. Liquid is filled at the same height, but quantity of liquid is different. Quantity of liquid, Q liquid here is greater, QL dash and QL double dash. So here the quantity of liquid is QL greater than QL double dash greater than QL dash. But pressure at the bottom, because height is same for each, so that pressure PA, PB and PC are equal. PA is equal to PB is equal to PC. It means there is pressure at the bottom, pressure of liquid is independent of size and shape of the container. It depends only the height, or we can say the depth of the liquid. If because we know that P is equal to H rho G, because P is equal to H rho G. Here rho and G are constant. Rho is density of liquid. Density of liquid, it is constant, and G is also constant. G is also constant. G equal to 9.8 meter per second square. It means P depends on H only. It shows that P depends only on H. One more example of this hydraulic press, that is hydraulic brake. आजकल हम देखते हैं गाड़ियों के जो जितने भी ब्रेक वो सब हाइड्रोलिक सिस्टम से होते हैं और उसमें बहुत इजीली मतलब बहुत अच्छा ब्रेक लग जाता है. हाइड्रोलिक ब्रेक सिस्टम इज यूज्ड इन automobiles to retard the motion. Hydraulic brake system is used in an automobile to stop the vehicle